Calculus in this unit won't be the hard part. The algebra is the hard part. And especially when it comes to like exponent properties. Your previous classmates have died 1,000 deaths in the classroom because they could not keep track of all their exponent properties. Especially down here, negative exponent property, roots, fractional exponents. These three down here are like death for the calculus student. So I wanted you to have the blue sheet. You've got it handy. It's a little cheat sheet. No, you cannot use it during a test or a quiz. That's why it's blue. I'll see it. Now, if you are so motivated, so dedicated to doing well in calculus that you get a tattoo of these derivative rules, well, that's different. That's also really strange. Please don't go the tattoo route. There are far better things you can do. Okay? Oh, teeth sucking. That was 10 minutes of TV time.
Right here.
Okay. Everybody good? All right. Derivative rules. What do we got? There are a whole bunch that we're supposed to know at this point. What do we got? Henry, what's one that you know?
If f has a relative max,
Oh gosh, that's so last unit. I mean like new derivative rules. The quotient rule. What's the quotient rule?
G of x times...
Okay, y equals f of x over g of x. What's the quotient rule?
f of x times...
Oh my gosh, so sad.
G of x.
Oh, so sad. Quotient rule on the count of three. 1, 2, 3. Oh, that was low. That's for darn sure. I heard low, which means g of x. D high, f prime. Low D high, and then what? Minus high D low. All over. Low. That's the quotient rule. We also have the product rule. Chris, how are you feeling about the product rule?
Good.
You've got f of x times g of x. Chris, how do we find the product rule?
F of prime of x times g.
F prime of x
times g of x
times g of x
plus f of x times
plus
g
f of x
plus g. Times g prime of x
times g prime of x. These are two derivative rules that we need to know. We need to know well. Then we've got the power rule. And we've known the power rule forever. The derivative of x to a power, you bring that power down and you reduce the power by 1.
Yeah.
Now, there's two other derivatives that keep showing up again and again and again. Derivative of the square root of x, I'm going to show that to you so many times, it's worth memorizing it. Now, I'm curious, has anybody memorized that yet? You've seen it enough times you know what the derivative of square root of x is? Paul has memorized it? Maybe 2, maybe 3, maybe 4?
X of 1.
What do you get, Sylvia? Do you have this one memorized? Okay, no. You're right that square root of x is the same as x to the half, but I'm asking it, have you memorized the derivative of it? What do you got for me, Michelle? Okay, 1/2 x to the negative a half. Is everybody okay with that? Because square root of x really is x to the 1/2 power. You bring that power down, you reduce the power by 1. An even better way to write this is going to be 1 over 2 square roots of x. Good. Nice job, Michelle. Okay, derivative of 1 over x. Another one worth memorizing. It's going to show up. Rebecca, you get this one? This is negative 1 over x squared. Rebecca, how did you get there? Somebody help her out. If you haven't had it memorized, Gonzalo, what would you do?
That would be x to the power negative half, and then you subtract.
Oh, I'm sorry. What was that?
The what?
Floor moved away from you because of what you just said. You said 1 over x is the same as x to the power negative a half?
Negative 1.
Ah, 1 over x is the same as x to the negative 1, and then what did you do, Gonzalo?
You subtract 1 and bring down the 1, so it's going to be like...
Floor moves further away from you with every word that comes out of your mouth. 1 over x is the same as x to the negative 1. Power rule says bring that power down and reduce the power by 1. So you get negative 1x to the negative 2, negative 1 over x squared. All the friends are okay? I am confident that you guys can all do all that, but I'll tell you, these two are going to show up so much, you just want to get them memorized. You want to get them locked down. Everybody good? Excellent. Oh my God. So now that we've got the product rule, we've got the quotient rule, we've got the power rule, I have 1, 2, 3 new derivative rules coming your way today.
Yay.
Yay! Good answer. The first one is the extended product rule. The extended product rule is for when you are multiplying 3 or more functions together. So I know I wrote it as y equals UVW. I want to change that. Y equals f of x times g of x times h of x. 3 different functions being multiplied together. I'll tell you what the extended product rule is, and you're going to say, oh, of course it would be that. That makes sense to me. So if I have 1, 2, 3 things being multiplied together, here it is. F prime of x times g of x times h of x plus, any guesses?
Plus f of x
F of x g prime of x
times h of x
times h of x, love it, plus f of x
times
g of x
times prime of h of x.
times h prime of x. This is the extended product rule. What just happened? You take the derivative of the first one, multiply it with the next two. Plus, now you take the derivative of the second one, leaving the first and the third alone. Plus, you take the derivative of the third one, leaving 1 and 2 alone. This is the extended product rule. How many of y'all believe me? See, that's because you are naive and you just think everything that comes out of my mouth is the truth. Sometimes there are lies, so we're going to prove it. Yeah. A good proof. So here we go. Let y equal f of x times g of x times h of x. What I'm going to do is I'm going to group these guys together. I'm going to say f of x is the first function, and g of x, h of x is the second function. Now I'm multiplying these two functions together, so I want to use the product rule. The product rule works when you're multiplying two things together. What does the product rule tell me to do? It says take the derivative of the first part, which is f prime, and now what? Multiply by the second one, like leave the second one alone. Derivative of the first, leave the second alone. Plus, now it's f of x times the prime of all this stuff, the derivative of all these things over here. And here's where I'm going to write that. The derivative of g of x times h of x. Derivative of the first, leave the second alone, plus the first times the derivative of the second. The reason I want to write it this way is I'm not ready to find this derivative. I know I have to, I'm just not ready. I'm just too tired. How am I going to find the derivative, though, now in that second piece? How do I find the derivative of g of x, h of x? Henry sees it? Quotient rule? I don't think quotient rule. Henry, what do you got?
You get it for number 2.
Like, to find the derivative over here?
Yeah.
What would you do?
You will do g of x times h of x.
Right, this is a product rule. We're in the middle of a product rule, and we get the benefit of doing another product rule. Well, how do I take the derivative here? The derivative of a product, it's g prime of x times h of x plus g of x times h prime. But everything gets multiplied by f of x, and I'm going to add it to all the stuff over here. Now, let's do a little bit more algebra. I want to clean this up and you'll see it. F prime of x times g of x times h of x plus, I'm going to distribute the f of x through. F of x times g prime times h plus f of x times g of x times h prime of x. Ta-da! Adrian is so unimpressed. Ta-da! The derivative of this product of three things is derivative of the first, leave the next two alone, plus the derivative of the second, leave the first and third alone, plus the derivative of the last one, leave the first two alone. You're not going to have to prove it again. That was a once-in-a-lifetime opportunity. It is come and it's gone. Everybody okay? Ish? Jackie? Can you still do the squared thing? Instead of saying ta-da? Yes, honey. If Mr. Link raised you to do like the little box at the end, that's okay.
No,
Is that what you're asking?
no, I mean like, if we find that way it takes too long for some of us to still do like the box method.
Oh, I know what you're talking about. It depends. Show me what you can do with this next one. Use your newfound skills. I can't wait. Whoever's birthday is closest to mine, oh, by the way, that's this Friday, you're in control of the cups. Don't forget it's this Friday. Can't wait to see what the kids in Ohio are going to get me for my birthday. Better express it today. It'll be here on Friday.
I know I confused her since September. Your sister.
So the square is like
I'm the same amount of birthday. Oh, this is 25th. Yours is 24th. I know hers the 20 minus 4. 20 minus 4. Messing with my feelings. My mom's the 25th, so that's why.
So you just do 2 times 3 will give you 6 of it.
Oh, just this.
Wait, couldn't you just...
Okay, quick show of hands. How many of you guys are finding a way to use the extended product rule here? Diego's found a way, Paul's found a way, Michelle's found a way, Chris thinks he's found a way. Diego, how is it that you're using the extended product rule here? You heard something else. Chris, what are you saying?
See, like the variables right there, you just label them as f of x, g of x, and h of x.
What do you mean though? Are you calling like 3x squared f of x?
Yeah.
Okay, but the problem is the product rule is for multiplication. And that 3x squared and the 5x's are being subtracted, the 2's being added. We're looking for something clever here. I think there's something happening here. Karina, what are you saying?
Do we use one of these?
Maybe you could use one of these. Now, what I saw Sylvia do, and Sylvia started doing a box. She started doing 3x squared minus 5x plus 2 times 3x squared minus 5x plus 2 times 3x squared minus 5x plus 2. Sylvia must have some great algebra skills because what she's going to pull off is going to be a minor miracle. But I think there's some good stuff happening with Sylvia's idea. 3x squared minus 5x plus 2 cubed means 3x squared minus 5x plus 2 times 3x squared minus 5x plus 2 times 3x squared minus 5x plus 2. It means take that same base and multiply it 3 times?
Yes.
Anybody seeing the extended product rule yet?
Yeah.
Yeah, what does that extended product rule tell you to do? This guy times this guy times this guy. The extended product rule says take the derivative of this guy, and then what?
Multiply by the other 2.
Multiply by the other 2 left alone. What's the derivative here?
6x
Minus 5.
6x minus 5. That's the derivative.
Yeah.
Times 3x squared minus 5x plus 2, 3x squared minus 5x plus 2. You're not done.
Do that again.
Now do it again, but be careful. We're adding, but now which one do we take the derivative of? The second one. What's that derivative? 6x minus 5 times 3x squared minus 5x plus 2 times 3x squared minus 5x plus 2. Plus...
Same thing.
Same thing! Go to the third one. Derivative of the third one.
3x minus...
Oh, awkward. 6x minus 5. 3x squared minus 5x plus 2, 3x squared minus 5x plus 2, 3x squared minus 5x plus 2. Love! What a great answer for free response. Will never show up on multiple choice. Ever.
What's the first one?
Why not? What else could you do? Not calculus, algebra. You see like terms to combine? Where? I don't disagree with you, but where do you see them?
The 3x. We can have just 3x squared minus 5x plus 2 to the power 18.
Okay, so you don't like writing 3x squared minus 5x plus 2 times 3x squared minus 5x plus 2. It sounds like you want to say this is the same as 3x squared minus 5x plus 2, the whole thing squared? That works. And we can do it again over here. And we can do it again.
Can we just do the whole thing like that?
Now I want to be careful. Get 6x minus 5 times 3x squared minus 5x plus 2 squared. Plus another 6x minus 5 times 3x squared minus 5x plus 2 squared. Plus another 6x minus 5 times 3x squared minus 5x plus 2 squared. That's good. There's a better way to write that.
Not cubed.
Not cubed.
Square.
Not squared.
4.
Stop guessing, because your next one you're going to say is fifth power, and that one's wrong too. Jackie, what else could you do? Karina.
Is it like the cubic the equation like I forgot, like it's A B.
Okay, like sum of two cubes, difference of two cubes. We're definitely going in the way wrong direction here.
No.
Oh, bail me out here. Can you add all the exponents? What does that mean?
So like, since it's squared for all of them, it can be 2 plus 2.
Oh no.
Oh, 2 times 2 times 2.
Oh gosh, no. Okay, let me stop embarrassing you guys here. 6x minus 5 times all this one time, right? Plus 6x minus 5 times 3x squared minus 5x plus 2 squared a second time. Plus 6x minus 5 times 3x squared minus 5x plus 2 squared a third time. Marilyn?
You just put the whole thing to the power 3.
Oh! Oh, I'm too old for stuff like that. Oh my God, no, Julissa. 3 times 6x minus 5 times 3x squared minus 5x plus 2, the whole thing squared. Sorry, I know I'm too old. You guys think I actually was having a heart attack. Don't worry, I don't have a heart. It won't happen. That is the best, most simplified answer you're going to come up with. And the DC friends are like, why didn't you just do the chain rule? That's okay. The AB friends, is everybody kind of okay getting here?
Yeah.
Okay, good. Put a pin in this. We're coming back to it.
Oh.
Yeah, oh, Sylvia. All right, let's keep pushing. Keep pushing. New derivative rule. The chain rule. Sylvia, you're such a good reader. The chain rule is for, you're going to see the connection in a minute, mind will be blown. The chain rule is f and g are differentiable functions, just means derivatives exist. Then the derivative of the composition, you guys may remember from pre-calculus, you would talk about like fog of x, f of g of x, a function inside of a function. We can be found in the following way. So derivative of f with g of x inside, we're going to read this as f of g of x. Here's the chain rule. You take the derivative of the outside function, leave the inside function alone, times the derivative of the inside function. So it's f prime of g of x times g prime. That's the chain rule. Derivative of f of g of x f prime of g of x times g prime. For those of you that are looking for a way to remember this, I always think about the chain rule as a mom and her baby. Stay with me. It works. Where's the mom?
The big one.
F.
F should be the mom, right?
Yeah.
And where's the baby?
Inside her.
It's the inside. There's the little baby. Okay, Henry's like, is that how it works? Yes. Okay. F is the mama. G is the baby. What the chain rule says is you take the derivative of the mama and you leave her baby alone. Times the derivative of the baby. This is the chain rule. That's the miracle of life. I don't know what's going on there. So chain rule, when you're doing composition of a function, derivative of the mama, leave her baby alone, times the derivative of the baby. Say it with me a couple of times. Okay, chain rule says? No, say with me. Stay with me, Paul. The chain rule says derivative of the mama.
Derivative of the mom.
The chain rule says? We take the derivative of the mama. Leave her baby alone. Times the derivative of the baby. Okay, faster and together. The chain rule says take the derivative of the mama. Leave the baby alone. Times the derivative of the baby. Okay, just the good-looking people. The chain rule says way too many of you. The derivative, take the derivative of the mama. Leave the baby alone. Times the derivative of the baby. This is the chain rule.
This is chain rule.
Okay, Andy, that part's over. Okay. Another way you're going to see it in a textbook is sometimes they're going to actually break apart the two functions. They're going to say y is a function of u, but u is a function of g. When that happens, the way that you find the derivative is you find the derivative, it's going to be the derivative of y with respect to u times the derivative of u with respect to x. It's the derivative of y with respect to u times the derivative of u with respect to x. Jeanette?
How will it look like on the AP exam?
You'll see that in just a moment. You're so good. Everybody okay? Stay with me. Alright, so just a little side example here. Okay, that problem we just did, we said k of x is 3x squared minus 5x plus 2, the whole thing cubed. We just did this problem. We just went through the pain, the agony of the extended product rule. Because that's all we knew. But now there's a chain rule. The chain rule is for when you have a composition of functions. You have a mama function and you have a baby function. Does anybody see the baby? Where's that baby? Where's that baby? 1, I see 2, I see 3, I see 4 maybe. Do you have an outside function and an inside function? Usually the inside function is easy to see. Daisy, what's the inside function?
Wouldn't it just be 3x minus 5 plus 2?
3x squared minus 5x plus 2 is the baby. It's the inside function. What's the outside function? Cube. The fact that we're cubing. Now that means that like, that guy's the mama, but really your mama is like stuff is getting cubed. Let's find the derivative. The derivative says, take the derivative of the mama. What's the derivative of stuff cubed?
3 stuff.
3 stuff.
Squared.
3 stuff squared. Like if you were taking the derivative of x cubed, it would be 3x squared. So 3 times your stuff squared, don't stop, times derivative of the baby. Derivative of the baby, anybody see it? 6x minus 5. Some of you just went, in the words of my 13-year-old, sames. Same answer as that extended product rule, but guess what? So much faster. Chain rule, so much faster. Henry?
That's it?
Yes. And that is exactly the same as what we just did with the extended product rule. Chain rule is for functions inside of other functions, composition of functions. You know.
So the extended product rule is for multiplying different types of functions?
Yes. Yes. All right, friends. So let's fix it up. Let's fix it up, fix it up, fix it up. And if you guys go to the next page, it says check for understanding.
Yeah.
And I completely blew it. Completely blew it. I'm asking you to find derivatives of functions that you don't know. Okay. There are 4 problems. All the cups are on green. Person whose birthday is closest to mine, you're in control. I need you to fix your functions. Okay? This guy here is going to be f of x, x to the 5th minus 5x squared plus pi to the 4th power. H of t is going to be the cubed root of t squared plus 2t. Number 4, j of theta is going to be square root of theta plus 1 over theta squared. See what you can do. We'll talk in a bit. Hi.
So it looked to me like you did is you said, let me cube each of those terms, and that's not a thing. That's not a thing. That's a J.
Oh my.
That's a
Mr. George, what does that say? 1 over what?
It actually says nothing. Wait. Yeah, it's not saying anything. Okay, Chris.
What does it say?
Still nothing.
Alright, what does what does J?
J of theta is the square root of theta plus 1 over theta, the whole thing squared. This Karina enjoyed that.
Isn't it plus 3?
I can't like do that.
Yep.
We can just leave it like this. Do something.
Some of it I like, some of it I don't like.
Oh, wait.
So how do you do this? It's a 6.
But the way you take the derivative of like something to the 6th power, you bring the power down, and then you reduce the power by 1 power. So baby is the stuff inside.
I'm saying
Mama
G
is
prime,
stuffed
yes.
to the 6th power.
Like the real one.
So if all goes well, that means that G prime is going to be 6 times x to the 4th plus 3x to the 5th power.
Yeah.
Right? Derivative of x to the 6th, 6, x to the 5th. Don't stop though. Times the derivative of the inside, 4x cubed plus 3. And I have to see the parentheses here. Otherwise, if we forget to write them, someone's going to say, oh, multiply all this by 4x cubed. And then add 3 on at the end? No, I need everything being multiplied by the derivative of the baby. How many guys had that as your derivative? Okay, good. We're in a good place. Keep going. If you need help, use those cups. You go.
Okay. So the inside function is this x the outside function is so the derivative of 4 times all that stuff. You bring that power down and you reduce the power.
We don't put the pi on the derivative, we don't put the pi on the So you get 4 parentheses
Like this?
5x minus 5x squared plus 5 times
Oh my gosh.
to the 4 10x.
All right. I see baby. See that baby on the inside. Adrian, stay with me.
How do you get the derivative of pi?
Derivative of stuff to the 4th. 4. X to the 5th minus 5x squared plus pi. The whole thing cubed. Times derivative of the inside. Yep. Okay, how many guys get the second one?
Oh no.
Okay, we're in a good place. Now, let's club it together on this one. Cubed root of t squared plus 2t. Gonzalo, what's up? How on earth are we going to find the derivative of the cubed root of stuff? Gonzalo, what are you going to do?
I put t squared plus 2t parentheses to the power of 1/3.
T squared plus 2t raised to the power 1/3. First of all, is that legal?
Yes.
Is it helpful?
Yes.
Michelle, why is it helpful?
Because then you can bring in the 1/3 to the at the front of the function.
Okay, so 1/3.
And then it'll be t to the
Oh, no.
no, t squared.
It's just going to be t squared plus 2t.
And then you
What happens to the
reduce
x
it
bar?
by 1.
Subtract by 1, so that's going to be to the negative 2/3 power. And then?
And then you do the derivative.
Derivative of that baby, which is 2t plus, 2t plus 2. Bring that power down. Reduce the power by 1, but that baby gets left alone. Times the derivative of the baby. Andy.
So now that we know the chain, we don't have to do the extended.
If you see this as a chain rule problem, and it is a chain rule problem, then you don't have to do the extended product rule.
Is it negative?
I'm really interested to see what you guys can do with this next one. I'm not going to talk to anybody. Take a minute, work with the folks around you, see what you can do. Good luck, God bless. I have faith in your sparticle particles.
What is this?
What? Oh, I'm not going to tell you which one. You're going to have to know which one. No, no. I'm going to say find the derivative.
I didn't choose the problem.
It's not. Well, the problem is you don't know how to find the derivative. Okay, and some of them are right and some of them are wrong. But we're not going to have any conversation about it because I did not intend for you to have to work on that one. Nice. Oh, wait. No. Close. Gonzalo, you doing okay there? Nice. Keep going. There are hard problems on the back.
It's going to be 1 half theta.
Keep going, son.
That's a lot of
To the
brain.
power of. Is this
Extended chain rule.
Are we supposed to?
Bam. You don't have to simplify.
No.
Change that function.
Nice.
I mean, I do have it right.
Smart and good looking. You can stay.
So it's right.
Bam.
In a way. It is.
Love.
Oh, it's mine, right?
All right, there's. Ooh, I gotta come back to Jackie, otherwise she's gonna feel neglected. Nice.
Oh, like, what do you do? Like, square.
All right, here we go.
It's not.
Here we go. I want to take the derivative squared of theta plus 1 over theta, the whole thing squared. Clearly, that stuff inside the parentheses is your baby.
Yes, sir.
I'm taking the derivative of stuff squared. So it's going to be 2 times the square root of theta plus 1 over theta to the first power. Of course, you don't have to write to the first power. Times derivative of the stuff on the inside. And the derivative of square root of theta, everybody knows.
1/2 of theta to the power of negative 1/2.
Okay, so 1 over 2 square roots of theta, or 1/2 theta to the negative 1/2, sames. Derivative of 1 over theta? Minus 1 over theta squared, or minus theta to the negative 2 power, same.
Same.
Everybody feeling really good about chain rule?
Yeah.
We got this under control. Nice. Nice, nice, nice. Good, let's go to the hard problems then. Oh, don't be a weenie. I want to take a trip to Big Mama's house.
Yeah.
All right. Okay. So, there are some times when it's not just a function inside of a function. There could be a third function. It's gross. Don't think about it too much, Henry.
They're twins.
No, not twins. Twins are not born that way. A function inside of another function, inside of another function. No. Shh. Think turducken. Turducken. A turkey? No, honey, not inside of the duck. The turkey's bigger. It wouldn't work well. Turducken, you start with the chicken, and then what do you do with the chicken? Put it inside the duck.
And then you put that in the turkey.
And then you put it inside the turkey.
Oh my God! What?
This is turducken. And then you go to the emergency room because it's too much. Okay. So stay with me. The extended chain rule, much like turducken. There's a baby. There's a mama. And then Big Mama. Now, some folks are like, that's not what we refer to her in our family. Maybe it's the baby and the mother and abuela. Whatever you want it to be, baby mama, big mama. Here's how it works. You take the derivative of the outside function. You take the derivative of Big Mama, but you leave her babies alone. And then what? Take the derivative of her baby. You take the derivative of g of h of x. And you might say, but we're not done.
No.
Because I have g of h of x. This is another chain rule. And how does that work? You take the derivative of the mama, leave her baby alone, times the derivative of the baby. You know that was loud enough that I heard it, and so did the kids in Ohio. Okay, so extended chain rule says f prime of g of h of x times g prime of h of x times h prime of x. You start on the outside and you keep taking derivatives, one layer at a time. You're not going to cry. Okay. Here we go. I want to go down to example number 4, all the way at the bottom. You're not going to cry, you're just going to want to cry.
I'm already crying.
All right, let f be the function shown at the right. G is equal to f of the square root of x squared plus 1, and we want to find g prime of 0. We've got some function over here, this guy's little f, and g is f of the square root of x squared plus 1. Every time I'm saying that word of, it is an audible clue. Chain rule. F of, there's stuff inside. Square root of, there's stuff inside. How would we find the chain rule? How would we find the derivative here? f of square root of x squared plus 1. You're not getting me started.
Can we just change the square root to 1/2 times x squared plus 1?
Okay, so you don't like the way it's written and you want to make it x squared plus 1 to the 1/2. That's fine by me. Fine by me. But it's still going to be f of x squared plus 1 to the 1/2 power of somewhere in there. Paul, what do you got?
Can you do the mama thing?
Okay, which would tell you to do what? Where do you start?
Can you start at f times square root of x squared?
Careful, this is not f times. This is f
Oh.
of f inside with stuff inside.
Yeah.
So the chain rule says take the derivative of the mama. And then what?
Leave the stuff alone.
Leave the baby alone. Then
Plus
times the derivative of the baby. I really like this notation because I'm not ready for all those derivatives to happen yet. F prime of that times the derivative of that. This should be really easy. Derivative of square root of x squared plus 1 is 1 over 2 times the square root of x squared plus 1. You've got that form memorized. Times 2x. So the whole thing is f prime of the square root of x squared plus 1 times 1 over 2 times square root of x squared plus 1 times 2x. Yep.
The parentheses.
And you could use parentheses if you want to. Because it's just one term, you don't need the parentheses. They wouldn't add anything into the problem. That's great. That's g prime of x. Don't fall for it, though. Don't fall for it. You guys are too smart for this. Now you got to plug in 0. So, okay. G prime of 0 is f prime of the square root of 0 squared plus 1 times 1 over 2 square roots of 0 squared plus 1 times 2 times 0. Anybody know g prime is 0? Anybody know g prime is 0? This should all be 0. Right, whatever this is, times this stuff over here, times 2 times 0, 0. Done.
So you don't use the graph?
You actually did not need to use the graph in this case. Karina.
Can you explain how you got the derivative for the first one?
How did I get the derivative of what?
Of b of x. I mean,
The derivative of this guy here? You're taking the square root of stuff, so the square root 1 over 2 square roots of the stuff times 2x. 2 nights homework, assignment 38. Round 1 and round 2 you already did last night. Round 3, get it done.
Yes, sir.
Thank you.
I should have prepared for it.